I'm going to be doing 2002 AP Calculus BC question 3, and yeah, this graph is the path of a roller coaster, and the x position and y position are given. The x velocity and y velocity are also given, and for A we're asked for the slope at time equals 2. The slope of a path is actually just velocity, and velocity is the first derivative of x and y. So yeah, so we just look for dy dx, and yeah, and we plug the t in, so, and we get 1.793, and that is in meters per second. And for part B, it's kind of more complicated. We're asked for a acceleration vector when the position x is equals 140. So we need to use the position to get the time, and after we get a time, we plug it into the second derivative to get the acceleration. So here's how I did it. So yeah, we know that the position is 140, and we use the position equation to get the t, and so this is the t. After I got the t, I took the derivative of the first derivative equations, and then I plugged the t in, which give me the acceleration of x and acceleration of y. And to make it a acceleration vector, you just need to put it in brackets in yeah, just x and comma y. And for C, we're asked for what is the maximum height and the speed when it's in the maximum height. So once the car is at the maximum height, that means it's not moving up or down, because if it's moving down, it's not the max, and if it's not moving, it is the maximum or the minimum. So yeah, and so since we know at the highest point, when something is in the highest point, it's not moving, we can tell that the y velocity, it's going to be equal to 0 at that time. And we found out that the time equals 3.023, and now that we know the time, to find velocity, we can use like a triangle formula. Since yeah, so if we want to get the v over here, we can square y velocity, square x velocity, and put it in 1/2 power. This is just Pythagoras theorem. Yeah. So yeah, after I plug the number in, which is really simple because we know y velocity is 0, so we can just ignore this part. And so yeah, we just plug the t into this equation, and we can get 6.027, and that is how fast a car is moving horizontally when it's at the highest point. For D, whereas there are 2 times where the car is at the ground level, and we need to find that time and write the average speed between it. So when the car is at the ground level, which means the position, y position, the height position equals 0, and when we plug that in, we can get the time t, and there are 2 times stated in the question, and we actually found 2. So if we want the average speed of something, the general equation is just the speed times time, and this is just the area under the velocity graph, which is just v times t. Here's an easy example. If this line is the velocity, that each dot equals the velocity, we just need to time it by the time, like on every instant, and then which means the area equals to how far it traveled. So we just need to know how far it traveled over here, and how much time it spent, and it just t2 minus t1. So if we expand it, it would be 1 over 4 pi minus 2 pi, and then the integral can be expanded into this form, the Pythagorean theorem. Yeah, and yeah, that's it.